Hi guys, so welcome back to the second part of this video. So in this video, what I'll do is in goal programming, I will uh, go back to the same sum that I was covering in the first video, and I'll show you what happens. Okay, so let me minimize this. Yeah. So the question that was given to us. So I'll read out the question again very briefly. So it's there is an ad agency that requires that is creating the media schedule for a TV client, and they want at least 65 million HIM, 72 million HIW, and 70 million LIP. Uh, the total budget is 7 lakhs, and the advertising cost is given in a table. So this is the cost per ad, and this is the number of HIM, HIW, and LIP per exposure of that ad. Okay, 1 minute ad of each type will be shown, at least 2 ads for sports, news, and drama, and 10 ads for a single type of show. Max 10 ads for any single type of show. Now, the first thing that we are going to do is, firstly, before you do goal programming, you have to check whether is there even a need for goal programming. So what happens if I run the solver like this? So this is the table. So this is the table. These are the number of advertising plans. I'll make them 0. Um, the budget is basically some product equal to some product of this cost and comma advertising plan, right? And these balances are again some product of HIM, HIW, and LIP multiplied by advertising plans. Okay, so these are the basics. Now let's run the solver over here and see what happens. So if I go to data and then go to solver, okay, and so my objective would be to minimize the cost, and changing variable says these things. Okay, by changing variable says subject to these constraints. Now if I solve this solver equation, you can see that sorry, one second, right, the solver. So um, one constant I had to add was that this is less than equal to this value. Okay, okay. Now if I run the solver, what happens is you can see that keep solver solution could not find a solver could not find a feasible solution. What this means is that because your budget is constrained, you can see 70 it has covered, but here out of 72 only 62 has been covered, and out of 65 only 63 has been covered, which means that the solver is not able to give a perfect solution in this case. That is why we need goal programming. Now, there's a first reason why we need goal programming. So let's do this using goal programming. The main change will be over here. Okay. So what this table is that it says that this is the exposure. This is the same as the equation that we used. HIM would be HIM column multiplied by advertising plan. Again, all the 3 columns, you know. Now, what this is saying is this is under goal and over goal. So if it's under, so let's say, like you can see here, there is 62 exposures plus 3 under the goal. So my goal is 65, but these are 3 under the goal. And over the goal would be in case there is 70 and you have 76 exposures. So it's over the goal, correct? Now, the first case that we will be doing is given in the question. It says that assume all the goals are equally important, right? Um, so if all the goals are equally important, what I will do is I will try to find an optimized solution which gives the most optimum solution for a for the entire model. Okay. Now, two things you need to know where you to use minimum and maximum deviation. So this is an advertising plan. So I, as an advertiser, don't mind if in any case the advertising plan goes. So if I reach more people than I require, that is required, that is not a bad thing. So that is where maximum over deviation is fine. If it's over the limit is fine, but minimum you should reach the uh, limits. The threshold limit should be reached. So 60, you should try and hit these targets and with the minimum deviation. So that's why what we do is we have this minimum over deviation and maximum over deviation. What is this? So this is equal to sum of this under goal. So this is the sum of under goal, and this is the sum of the over goal. correct? Now if there was a question where it says that, okay, you need to send, like the next question that we have of Tata Motors, uh, if you're reaching more people, or let's say there's something where if you reach more people there's a more loss, so there you need to minimize the maximum over deviation. Okay, uh, in this case, because it's a ad, and if you run more ads, it's better, so you have to minimize the under deviation. So that's why our objective over here would be to minimize this part. So I'll color this in green. Okay, so what does the program have to do? Firstly, it will figure out what is the advertising plan and under deviation and over deviation, keeping in mind the budget constraints. Okay, so what I'll do is, and here we'll not minimize constraint, because we know that there is no constraint. There's no point in minimizing budget, because budget is anyways not enough to uh, meet all the three goals. So what is my constraint is, need to minimize this. So this is my minimizing equation, correct? Now I'll again go to data, go to solver, and see, my objective would be to set this cell. So firstly, I'll let me reset everything. Okay, so my objective will be to minimize this. So click on this, go to minimize. Okay, so this is minimizing. Now what cells will be changing? It will change these cells. So firstly select this area, then comma, and then this entire area, green and yellow. Now what are my constraints? So the first constraint that I have is my budget. So it says that this should be less than equal to 70,000. Okay, first constraint done. Second constraint that I have is, it said that this should be less than, should be more than 2. So it, in the question it said, so I'll read out the question. It says that at least the client requires at least 2 ads to be placed in sports, news and drama. Okay, sports, news and drama. So I'll go back to Excel. Okay, so first is sports. So sports is this one, should be less than, should be greater than 2. So greater than 2 add. Then is news, news greater than 2 add, and then drama is this, greater than 2 add. Okay, now also these advertising plans should also be an integer, because it's an ad, so it can't be a part ad. So it should be an integer. Also it says that requires no more than 10 has to be placed on a single show. So what I will do here is go to cell reference and select all these cells, and then write that this should be less than equal to 10. Okay, so these are my goals. So I've done everything, I think. Click on cancel. So these are all my goal programming goals. um, okay, let's run and see. So this is the budget. This is the three shows which require more than, so I think this one I have to edit a little. This was greater than 2. Okay, so this should be greater than 2, this should be less than 10, and this should be integer. These are all my goals. Now let me solve the problem. Okay, so let's see what happens. Oh, I missed one thing. So what I missed was, so I'll show you first. So this balance equation, so balance equation is what? So balance is equal to exposure plus under deviation minus over deviation, right? So whatever is your um, exposure, so exposure will be always less than goal, because, or it can be more, but the total exposure will never be able to meet the goal. So this is the exposure plus under goal. So why plus under goal? Because if it's 65 and 60, so 60 plus 5 equal to 65. So here it will be under goal and this will be over goal and balance. So this is equal to this plus this minus this. Okay, now let me click solver, and there should be another constraint, that this should be to add, this balance should be equal to, exactly equal to goal. Okay, and click on OK, and now run solver. Now you will see that my under deviation is 11 and over deviation is 6. So it says that this is the most optimum solution that we can get by exhausting the entire budget. Okay, so this is what we get using code programming. Now this is something where we did so this question, uh, we have taken that all the goals are equally important. So in the next question, what we will do is we will take one by one each uh, goal, and it says that the priority levels are given. So assume all the goals listed are in descending order of importance. Okay. Okay. So that's how we will try and figure out how to solve the solver in the next question. So okay. So this is the second part. Now I'll do the third part.